This is Terry, and on this video, we're going to talk about radicals. So let's look at our first problem here. We have 3 square root of x plus 8 square root of x. So when we're talking about radicals or square roots, what we're going to look at is what's underneath the square root. So underneath ours, you notice we have an x in one and an x in the other. So if what's underneath the square root is the same, and here we do, they both have x's, then we can do what's in front of the square root. So let's look at that. We have a 3 and an 8. So it's basically saying 3 plus 8. And what is 3 plus 8? We know that to be 11, right? All right, so we can add those because the things under the square root are the same. So once we do that, we just bring down what's in the square root. We don't add what's in the square root together. It's almost just like it's a variable there, and we have to make sure it's the same. It's just like when we were adding or combining like terms. That's basically what we're doing here. This is a like term because they both have the same thing under the square root. So we just add what's outside of the square root and then bring down what's inside the square root. And that is our complete equation. Solved. All right, so let's look at the next one here. We have 8 square root of a plus 4 square root of x. All right, so when we're looking at that, remember, we're going to look just what's underneath the square root first. And we have the square root sign. And we have an a under one and an x under the other. They are not the same. And since they are not the same, we can't do anything with these two. So we would literally, the answer is going to be the exact same thing because we can't add the stuff in front of it because our, whatever's underneath that radical sign, underneath that square root sign is not the same. So we cannot combine. So that one just stays just like it is. Not too bad, huh? All right, so let's look at our next one here. We've got square root of 2 and then parentheses 3 plus 2 square root of 2. Okay, so when we're doing this, we have like the distributive property. Remember, we talk about we do anything we can inside the parentheses. We can't combine that, right? We have a 3 plus 2 square root of 2. They don't both have the square root of 2, or so can't combine those. So we're going to look outside the parentheses. So we are going to distribute that square root of 2 to each thing inside. All right, so when we do that, we say square root of 2 times 3. We'll always just kind of put our whole number first. So we have 3 square root of 2. We can't multiply those two together because one's inside the radical and one's outside the radical. So we can't do that. Okay, so we have plus, we have square root of 2 times 2 square root of 2. All right, so the numbers outside the radical, we just have a 2, right? But the cool thing about this guy is the radicals are the same, correct? See how those are the same? So if our radicals are the same and we are multiplying, because here we're distributing or we're multiplying, we're just going to multiply that. What's 2 times 2? That is 4. So we have 2 square root of 4. All right, so we see if we can simplify. So 3 square root of 2 can't simplify at all. But 2, and what is the square root of 4? We know that it is 2, right? So that's like saying 2 times 2. So we have 3 square root of 2 plus 2 times 2 is 4. And that's as far as we can go with this expression. All right, let's try one more. I'm going to roll this screen down just a little bit. We can see it a little better. All right, and we are going to write down our new problem here. And it is going to be square root of 27x to the 8 over square root of 3x squared. All right, so we have a division problem. Anytime we have a fraction, we have a division problem, right? And remember when we talked about problems like this before, we talked about kind of breaking them apart where we had the number underneath the square root and the variable underneath one. So I'm just going to break it apart like this. This is going to say the exact same thing. It's just going to be easier for us to look at, okay? Just like this. So they're all still underneath the square root. We just broke the numbers apart and the variables apart. All right, so what we're going to do is we're going to look at our numbers first, okay? So we're going to look at this side first. And the square root of 27 divided by the square root of 3. So you can just type that in your calculator, or we can say they're both underneath the square root. So 27 divided by 3 would be the square root of 9, right? Okay, and then we have, if you remember, when we have variables that are the same, and they're in a fraction form like that, we're just going to subtract our exponents. So we have the top exponent minus the bottom exponent. So we'd have 8 minus 2. All right, so let's go a little further. We know that the square root of 9 is just 3. And then if we went ahead and we subtracted those two, we'd have x to the 6. 8 minus 2 is 6. All right, so we can go just a little further. So we have 3, and then we want to get rid of this square root sign over that variable. So if you remember, we write down our variable, and we take the number that is inside, and it goes on the top inside the exponent of the variable that's underneath, and then we take the number that would be outside the square root sign, which would be, if there's not a number there, remember it's like a little 2, and we're going to put the 2 on the bottom. So we're going to divide that exponent. And when we do that, we're going to get 3, and x to the 6 divided by 2. 6 divided by 2 is just 3. So we have x to the 3, or 3x to the 3. There we go, I'll get it right. And that is our final answer. We have just simplified that down.